So as I was telling about your different hormones, sex hormones. Right now we'll go with your transport of adrenal steroid hormones in the bloodstream. How the adrenal steroid hormones like your cortisol, aldosterone, okay, how they are transported in the bloodstream. Okay, as you can see, cortisol, it is 70% is bound to corticosteroid binding globulin. Okay, so cortisol, it is mainly bound to one protein. As I told you, these steroids will be bound to a protein. Transcotin, it is bound to protein transcotin. 70% of your cortisol, 22% of cortisol, it is bound to albumin, and 8% are free cortisol. They are not bound to any protein. Okay, so as you can see, maximum portion of your cortisol or maximum cortisol will be attached or will be bound to your what, your, you can say, your globulin. Okay, or you can say it is bound to your transcotin. Okay, and in case of aldosterone, 60% of aldosterone, it is bound to your albumin. Okay, just the opposite. Okay, and 10% is bound to transcotin, opposite to that of your cortisol. So cortisol maximum is bound to your transcotin, but here it is least bound in case of your aldosterone. Okay, in case of aldosterone, it is bound to mainly your maximum portion is your albumin, but in that case it is not bound to your albumin, it is bound very less to albumin. Okay, and as I told you, transcotin is produced in the liver, and its synthesis is increased by estrogen. Okay, transcotin is a protein, it is generally produced in the liver, and its synthesis is also increased by your estrogen, another hormone. Okay, so these are the things, as I told you, about your the adrenal steroid hormones, how they are transported in the blood. Okay, so always you remember, to be transported in the blood, the steroid hormones have to be bind with your some proteins. Okay, so mechanism of steroid hormone action, uh, this is not so much required. Okay, okay, then we'll see intracellular receptors. In intracellular receptors, how they are means attaching with that, and we'll see here model of your typical steroid hormone receptors. Okay, as you can see, it's like a amino acid. Okay, you can see means protein coupled receptors. Okay, as you can see here, first one is your this first one is your variable domain, interacts with the other transcription factors. Second point is your DNA binding domain, that is zinc figure, and third point is your domain for dimerization, and fourth one is your hormone binding domain. This is the hormone binding domain which nearer to the carboxylic acid, COH. Okay, so this is a zinc finger structure, this one. Okay, so like that the mechanism is there. And hormone catabolism and excretion, this is your estrone 3 sulfate. Estrone, this is a ketone form, so that's why estrone 3 sulfate. Okay, and how it is catabolized and how it is excreted out, we'll see right now. So in inactivation of steroid involves reduction and conjugation in gluconides or sulfate to increase their water solubility. So what it is saying, how these steroids are going to be deactivated, or you can say how these are becoming inactivated by following reactions. Two reactions are there. What are those two reactions? One is your reduction process, or either made by your conjugation process. Okay, due to reduction process or conjugation process, these will be reduced. These will be your what? These will be inactivated. Okay, how they are going to be inactivated? And they are converted into your what? They are converted from your gluconides to the or sulfate form. They are converted to your either gluconide forms or sulfate forms. Okay, why they are converted into these forms, gluconide and sulfate form? If they will be converted to these forms by these following reactions, either reduction or conjugation process, they will be converted to this one, gluconide or sulfate form. So that what will happen, the water solubility of the steroid will be increased. If the water solubility will be increased, they will be more soluble in your urine sample. Then they will be eliminated out from the body. So that is what it told. Your hormone catabolism means how they are going to be excreted out from the body. Okay, and most are catabolized by the liver and kidneys. So maximum they are going to be catabolized and anabolism. Catabolism means it's a destructive metabolism. Okay, so how they are going to be destroyed or how they are going to be catabolized? They are going to be catabolized by various enzymes of liver and kidneys. Okay, and as I told you, 60% of the conjugated steroids are excreted in the urine. Okay, max, and 20% live in feces. Okay, in the stool 20% will be released, 70% will be released with your urine, and rest will exit through the skin, means through your sweating. Through sweating rest of the things will means 10%. So maximum they are excreted out through your urine, 20% will be excreted out the stool, and very less quantity will be excreted out about with through the skin itself. Okay, so this is how the hormones are going to be catabolized and excretion. So when the question will be arising how they are going to be catabolized, then you can say either by your reduction reaction or either by conjugation reactions. Okay, so and due to that they will be converted either to gluconide forms or your sulfate form. Okay, which will increase the water solubility. Because of that they will be excreted with the urine. Got my point? How these hormones are going to be catabolized and excreted? Understood? So as you can see here, sulfate form. So this is converted into your sulfate form. Okay, estrone 3 sulfate. So this is having more solubility, water solubility. So it will be excreted out. Okay, previously it is estrone hormone was there. So it will be converted into your estrone 3 phosphate, and it will be excreted out with your urine. Got my point? Okay, structure of one hormone. This is the hormone parent hormone structure. What is the name of that? You can say this is cyclopentanoperhydrophenanthrene. Okay, cyclopentano. Okay, cyclopentano. Pentano means this is your 5 ring structure, na? So that's why cyclopentano perhydrophenanthrene nucleus. This is the phenanthrene nucleus. So that's why this is called CPP, CPPP ring. Okay, this is the fundamental framework of steroids. So this is the parent structure of your steroids. Okay, what is that form known as your CPPP, cyclopentano perhydro your phenanthrene nucleus. Okay, this is the structure of cholesterol as you can see here. So cholesterol has the fundamental steroid skeleton modified as shown. This is the skeletal structure for your cholesterol molecule. This is the cholesterol means, as you can say, that is the structure. This is the structure for cholesterol molecule. Okay, the structure of cholesterol with numbering is also shown below. Here I have shown the, so starting from here the 4 rings are there, A, B, C, D. This is the 5 carbon atoms ring. Okay, and as you can see the numbering 1 2 3 4 5 6 7 8 9. So here 10, then again here from started 11 12 13 14. Okay, 15 16 17, then this is your 18, this is your 19. Okay, so like that we are giving the numbering. Okay, so here it is 20, then afterwards again 21 22 23 24 25 27 27. So you can, cholesterol is nothing but a 27 carbon containing ring. Okay, so these are the chiral center. Biosynthesis of cholesterol, already I told you how these are going to be synthesized. Cholesterol, it is synthesized, okay, from this molecule. Okay, this is no need for you. From cholesterol, how other steroids are synthesized, that is required. So cholesterol is biosynthetic precursor for different types of steroid, as we have discussed, like your vitamin D, corticosteroids, sex hormones like your different pregnenolone, then progesterone, as we have seen in example. Okay, 17 beta estradiol, aldosterone, cortisol. So different types of hormones are synthesized from your cholesterol. So cholesterol is the precursor for all synthesis of all these molecules. Okay, vitamin D. Okay, vitamin D also calcitriol, as you have seen there. Okay, so how the vitamin D is produced, we will see. So 7 dehydrocholesterol molecule is there. So when sunlight will convert the dehydrocholesterol on the skin surface to vitamin D3. As I shown you how it is going to be converted. Cholesterol, it is converted to pre-vitamin D3, then vitamin D3. Then vitamin D3 will be reacting with your 25 hydroxylate. So what will happen, that will be reacted to form your 25 hydroxyl what is that, vitamin D3, and it will form your by the reaction also it will form your this one, finally it will form your 12425 OH whole 3 calcitriol. We have seen vitamin D3. Okay, so that is how it is synthesized. Okay, so this is about vitamin D3, as we have studied. Bile acids also, these are also synthesized from your cholesterol. Okay, and how these are formed? Oxidation in the liver degrades the calcitriol, cholesterol. Okay, oxidation. So liver will in the liver oxidation process will be there. Due to oxidation, that cholesterol will be converted into your what, your what is that, cholic acid. And cholic acid is most abound, means it is the abundant form of a bile acid, so that will be converted. So like that. Okay, so how these are converted? Cholic acids, amides. Okay, so that will be bile acids. So these are the different corticosteroids, already we have studied, like your cholesterol, corticosteroids. Okay, cortisol, aldosterone. Okay, all these we have studied. In case of your adrenal cortex hormones, sex hormones, these are the structure for sex hormones. Okay, already we have discussed all these. Okay, so this finishes your all the steroid part. Okay,